And that would be me accidentally starting the stream early. We'll just sit here for a minute, let other people join. Should play some hold music or something. Do 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 do. Okay. At least I know audio is working. I can see that. It's weird that we don't have stats yet, though. I guess maybe because it's not supposed to have started yet. Yeah, I don't know how YouTube handles that. Getting started early. Uh-oh. Ah. It's okay. If you are on, you can say hi in the chat. Once again, I got started a little early by accident. So I'm just letting it run for a minute while I finish getting set up here. Some people join late anyway. So if you have joined early because I started early, I apologize. I'm just giving everyone a few more minutes to join. I accidentally started early. You guys can see the nice live screen, title screen. Tonight, yeah, I don't want to start too early. It's an accident. One more thing I want to do. Get started here, and I might start a little early, just another couple minutes, guys, if you are on waiting. Trying to figure something out. Actually, let's couple more minutes. If you are on and waiting, thanks for joining. I guess it says I've got 4 viewers right now, so let's go ahead and get started a little early tonight, just a couple minutes early, and you guys can see what I'm doing. That way, you're not just looking at my title screen, my lame title screen. So tonight, I think we're going to be doing dungeon generation, just because and I think probably everyone else needs a little break from the world generation. I'll talk a little bit maybe about where I got with that. Excuse me. So let's thank the patrons. I'll thank you again at the end. I forgot to last week, but thanks, guys. Yeah, the patron payout came out just a few days ago, and it was a welcome show in my inbox. It was really nice. Thank you. And let's go ahead and right now, what I'm trying to do is I had written some dungeon layout code before, and so I'm trying to remember where things were set up. And so this was done 4 months ago, and hey, thanks for stopping by. I appreciate it. I really do. Plus, every little view helps. Yeah, thanks. Maybe someday I'll do some different times that work better for certain people. This is just the time that works best for me. 9 p.m. Friday nights. It's usually I have nothing going on. Anyway, I did some work before it, and I can't remember when I changed the grid size from 20. And apparently I never committed it anyway. So we'll just continue on with what we're doing. Okay. So tonight I'm going to be spending time in the blockhead tool, because that's where I can run these little block scripts. And prior to many weeks ago, I worked on dungeon generation. I'm trying to find the files. WorldGen. Hey Lando, how's it Lando Calrissian. How's it going? Yeah, thanks. So we're gonna I have this dungeon layout, and I can't remember whether it builds based on the size of the, and we'll talk about how it works in a second. Yeah, so we build it based on the cell size. I think I'm going to limit it to 80 for the time being. And so the map, yeah, okay. So let me just see if this is working like I want it to. Nice. Yeah, that's the thing is, so this week I've been on a new project, and so it's just been figuring out one puzzle after another, learning the new code. Everything is brand new. And so that's been taking a lot of my time. And at night I've been working on the rivers. Let's talk about that in a second while this runs. Let's bye NT767. See you next time. So well, I'll just talk about it. You guys remember the maps from before, and I was plotting. So last week I was plotting the major cities, I think is what I was doing, and getting to the secondary cities. And the thing is, I got that working again from before, and it was pretty clear based on the layout that I needed to work out actual river connections, so that when we're inland we know whether that small river actually flows all the way to the sea, because then I know that I need to buff up the probability of towns immediately surrounding that. And so then I started dealing with the rivers and the river graphs, and there was some things I need to fix there. And I just feel like maybe you guys are tired of seeing all that, so we're going to work on dungeons tonight instead. And so prior to, was it dungeon layout? Okay, no. Well, yep, it is. Okay, so So, and let's make that centered. So let's talk about, okay. So let's, and now we can talk about what I did before. X offset equals, let's see, I think let's do cells dot x size x divided by 2 minus x map. Okay, so we're going to move that over to closer to where we can see it. Yep. And so when we actually render this, let's do x offset plus t offset plus. Okay, let's execute the script again. Okay. Come on. That didn't work. Oh, it doesn't like something. Okay. Oh, I already did a variable. Okay. So x map offset. It's the problem with these scripts. I don't name my variables very well because they're all prototypes. And so I'm just kind of hacking and slashing. And that sometimes comes back to get me in the end. Whoops. So, well, we can talk a little bit about how it places the... You know, and I gotta... Well, we can relearn this together because I don't remember how it does it either. I actually looked at a lot of... so draw a line will actually make the line, I think. Well, let's see. Everywhere we do this, we're going to be calling set cell. So let's see. Draw. Count chocolate. Now I don't like to type. You know what? This is not going to work. These classes are going to have to... Yeah. I think that I need to generate this. You know what? As nice as it would be to you know, we're going to have to alright, so I know I want that offset in, and that'll help us when I'm actually plotting the... So this is the one that I built the world. This is the size for the world gen, which pulls in a section of the world, which is what it's doing right now, which is why it's taking a really long time. And so I thought it would be neat to adapt the dungeon generation to work within terrain, because it'd be neat even before we have real dungeon generation if we had like a wand or a debugging wand where we could point it at the ground and it would generate a random dungeon there in the ground under that piece of ground. And so this is kind of the prototype for that. But man, that takes a long time. I'd kind of forgotten it's coming. Okay, so this is from before, right? We had the water and stuff, and so then maybe we could pick a different area, or maybe just pick here and have it generate a dungeon underneath this land right here. And so I'm trying to revisit these scripts and remember how they work. And one of the things I'm going to want to be able to do is to place them somewhere. It just happens to be that's in the right, in a decent place right now, but really we'd want to be able to place it anywhere on the map. And so this dungeon has to be offset by some amount And so we're going to have the map offset. And I think that we want, let's change this. Let's find all of the X sizes and make them X maps. Hey Jeremy, how's it going? Welcome to the live stream. Oh, I'm not using X size anywhere. Okay, so I am using X map, so this is where I use it. So I jump it all over. Here we go. So let's change this to X map size. And yeah, and then we'll change. We'll leave this at X size because I think I'm going to want this in a minute. And so then this will be based on X map size. And we have our X map offset, which is, yeah, so now we can sort of have that. So I defined these classes in the code. There's a room that has a, an area and a center and width and a height and so on. And then these various things to do tunnel distances and things. And then there's the tunnels that define the tunnels. That's what gives us these ability to have like these tunnels that have bends in them. Well, first let's talk about, let's see. Okay, so we know we have an edge right here. So what I did was I wrote this thing that would, yeah, so we can't actually cancel. Can't actually easily go over there. But let's fix the problem first. And then I'll relearn the dungeon generation as we go. So first of all, we pick some number of rooms randomly generated between like 11 and 20. So random 10 added to 11. So we'll always have a minimum of 11 rooms, maybe as many as 20. Up to 6, time to razzle. Okay, so it goes through and it plots these random rooms, and I think if we then, so based on that's interesting. So it's plotting the size of the room. So so it generates some random rooms, doesn't place them anywhere necessarily. And then it goes through for every room. For every room, it figures out how big it is in. Yeah. So what's the ideal size? And then it goes through, where's the, I should have left more comments for myself. Okay. So are we placing these essentially, okay, so we are using grid positioning. Sometimes I have to take these apart. Okay, so we make grid cells based on the size of our room, and then randomly assign a cell to each room. We'll go through each room. Okay, so, oh, I see. Okay, so here we are, we're figuring out, find the max size. So basically going through every room of the main feature rooms, and these feature rooms are randomly generated based on size, but they could be also selected from pre-built rooms instead of just random sizes. If you knew your dungeon was going to have a certain room like an entrance with stairs, or um, a pit of death or something, you could put those in here and make that part of the rooms list. And so then we go through here and we go through the room and we find out what their maximum size is, and that's basically for those feature rooms, what I call feature rooms, which is these that generated those 20 rooms that generated. We figure out what the maximum size is, and then we make a big grid that. So if these turn out to be the maximum size is 10 by 5, it's not, because there's a really big one here. Then we'd make a grid where the cells were 10 by 5, and then we randomly place each of the rooms in there, which means that they're guaranteed not to overlap, right? You know what? This might be a good time to have the whiteboard open. So let me talk about what we're doing here. Is this the one? Yep. I recognize the little wiggly W thing. Okay, so when we randomly generated the feature rooms, we ended up with some rooms like this, and some little rooms like this, and a couple big rooms that are square, and maybe another. We ended up with a whole list of these. And so we figure out what the maximum size of all of these is, and we make a grid that size. Like this. And then we place each of these randomly in one of these cells. And we're guaranteed that they'll never overlap, right? So there's a whole bunch of these, and we place them in. And these could have been, we could have had, Mythruna supports rooms like this, so we could have had pre-built rooms like that. We could have had rooms, shaped like this. It just happens to be that this random algorithm right now is just building rectangular rooms. But they would have all found, because we built a grid on the biggest one, it would have found a place for all of these, right? And they were guaranteed not to overlap. But like this one, some of them might be, way over off in the corner. Let's actually, can I erase it? Oh, so let's pretend there was another little one. Okay, so maybe we end up with one little one down here like this. So we've got them far apart, sometimes close together, whatever. That's what we're doing in this right here. We're basically building that grid. The grid cells of all the different grids. Yeah. So basically build a list of each of these cells so that I can randomly pick them like from a deck of cards. And so for each room, I find one of those random ones. And so if we're empty, then basically we ran out of grid cells. That means we had not enough rooms. That's actually a bug. Failed to place that because we didn't create a grid big enough to fit all of our rooms. But anyway, so then I randomly select one of the cells, remove it, put the room in there, and this is actually where we want to Okay, so we create a random offset based on the size of the room. So we're not just placing them always at the upper corner or something. We randomize the placement of the room within that cell. And then once we finally got that, that's what we're doing here. And here is where I will add the offset. And I think, so we'll talk about that. Let's execute the script again, and that should put everybody over here. Not responding, it means it's doing something. Nope. Put it right back in the same place. So, add local. Dirt. So in JME, you know, when you have a, and same with MathD, basically, add would return a new version and add local adds it to the existing value. Okay, so this one should, oh, we don't like this. X56 is out of bounds for length 40. And that is in, so we're filling in the room. Oh. Yeah, room fill. That's the unfortunate thing. Okay, so we can't do that. We have to generate the room and grid space because it uses that to fill in the map, which is, 80 by 80 up in this upper corner. Let me go ahead and execute that so we have the, oops, I didn't save it. So that can't be where we do it. Okay, so once we have those rooms, and I'm going to try to see, let's break this up into chunks so I can show you what's going on. If false, okay, draw a line, that's fine. Okay, so I think what I was doing before can work, so we can see things better. I just also have to do it for the tunnels. So map offset. And then where's that draw line? I was just there. There it is. So we just have to do it in here too. X map offset plus Z map offset plus. Okay, but I think I've first let's make sure that everything is working, and then I'll break it apart and show you. Oh, somebody's still unhappy. $750. Shortest. Yeah, okay, so something I've screwed up. Oh. Okay. I forgot to put something else back. Okay, so now it should put it in the middle. Nope. In fact, everybody is a little messed up. So let's alright, let's look for set cell. Oh, I forgot. Yeah, X map offset plus Z map offset plus. Yeah, this is going to be the only way to do it. Oh, no, this is where I got in trouble before. Okay. The issue is that inside these classes it won't know what the offset is. And that's why I did it that way. Yeah, see, in these it would. But the room that's actually drawing it is not... I gotta solve this problem. I think I can go through all of the rooms and all the edges and move them. What is this even doing anyway? That's drawing the rooms. Why? So what is this doing? That's drawing the tunnel. Okay, so where? Rooms and edges. Edges have tunnels. And the tunnels connect. The tunnel has a start and an end. So I think before we render anything, who's calling draw line? Sorry guys. Yeah, so we don't do that now. Draw the connected edges. Well, here we are. Oops. This should work. And this, if I do this without changing anything else, it should render the tunnels in the wrong places. Right? No. I don't get it. Tunnel draw. Oh, tunnel draw. Why? Okay, so that's not going to work. We're going to have to do what I originally wanted to do, which, well, not originally, but... So this is where we draw everything. And so before we draw everything, we will go through each of the rooms. Go through each of the rooms and see, that's unfortunate. Tunnel. The rooms are in grid space. I cannot believe I'm spending, 15 minutes trying to figure out how to draw this offset. And the reason is because in Groovy, I can do something like this. Where I, once you create a class, inside this class, it's like a separate Java class. It's Groovy, but it doesn't have any access to your variables anymore. And so if you wanted to have something like an offset, you have to put it in a place, excuse me, that it could get at it. And so, yeah, and even this, is it going to complain about that? I think, whoops. Actually, we know we're not going to use it in here, so we should be able to get away with this. Get rid of those. And everywhere we were using this, which is nowhere. Okay, let's make sure it'll at least compile. Woo, no, it doesn't like something. Yeah. Oh, I see. It did like cells though? That's weird. Maybe it didn't. Alright, what we'll do is... Yeah, I'm trying to center the dungeon, because I need to be able to put the dungeons anywhere. And the dungeon's generated in its own space, and so if I center it in this map, it tries to draw outside of its own little space, so I need to center it afterwards. But because I can't have global variables that the inside, so these classes sometimes draw themselves. Like the tunnel has its own draw method that draws, but it won't have access to the global variables. So I'm trying to give it access to the global variables, and it's driving me bonkers. So if we do public static void initialize, and we set x map size, z map size, what is cells? Def cell, object cells. So then if I do this, I ought to be able to say, okay, I can get rid of this. You'll see what I'm doing in a second. It just requires so much gymnastics that I would not have to do in Java. Ironically, this is one of the cases where Groovy is actually harder to do some simple things because of trying to mix paradigms. Okay, so if I did that, let's just see if we can execute the script, if it'll complain. Okay, so it didn't mind that. And so then everywhere we would want to use max. So now everywhere we set cell, whoops. Of course, it occurs to me I could have done this a different way. Cells is actually an n-block cell array, and I have, yeah, that would have been better. I have the ability to wrap a cell array into an offset cell array, because I use it for inserting things into the world all the time. But see, now that I've got it in a place where Java and Groovy can see it together as static fields of a class. Okay, we don't do that, so let's set cell. We don't usually use those. Draw a line, just in case we do that. And so then we don't do anything with that. And so beep. Beep. Alright, now let's see if it works. Okay, it liked the script okay. Did it put it in the... Okay, it didn't put it where I wanted it, but it did move it. And why didn't it put it where I want it? "4x nested for loops" is what I like to see. These guys, yeah, but I mean this is standard XYZ 3D loops. That's pretty typical, actually. You know, XYZ. You'll see these all over the place in my code because I'm dealing in 3D. Now, apparently, X map size was 80. Oh, this should be offset by half the map size. Yeah, we're all about the hack and slash in Groovy. Yeah. Okay, now we can talk about how it's working. All right. So let's take the tunnels out. So let's not draw the tunnels. Draw the connected edges. False. Okay. So we could do this again, and we'll see just the rooms with no tunnels. Come on. Okay, now if we take the next thing out, which was hello, Frammy. Um, yeah, so I actually had a lot of trouble coming up with a good procedural dungeon algorithm. I looked online. I actually was heavily inspired by the way dungeon masters would actually generate a random dungeon, a randomized-ish dungeon for real pen and paper D&D. Because when I looked online, uh, there's a lot of the wave function collapse and stuff like that, but I really wanted a dungeon that felt like a human made it. And one of the approaches that a real dungeon master will do was, so one technique, and I remember this from back in the day. I haven't run a dungeon since the 90s, the 1990s. Yes, that is back when I played and ran role-playing games, um, where you'd roll the dice on a sheet of graph paper. You take your handful of dice and you'd roll them on a piece of graph paper, and so then they would scatter, and so then you would draw rooms around those and then figure out how to connect them. You're using human intuition at that point, and there's sort of there's dice rolls to decide whether you connect rooms or not. And so I kind of wanted to go with that. I looked at how NetHack and Rogue generate theirs. I did not like that at all. It's very good at what it does, but it wasn't really what I wanted, because they're trying to build a really compact map, and I don't really care to build a compact map. So that's where I end up with this approach, where I sort of divide space up big enough for the main rooms, and we'll see that when I take this next part. So this is the infill room. So let's just look at the feature rooms. And come on. Okay, so when we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, huh. Is that true? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our random roll must have been 0. Do I say how many rooms? Generating 11 rooms. Yeah, so so the irony here is that when we did this, yeah, I actually still have some of that up. Is this it? Yeah. So I started out, there's this guy who has this sort of one sheet dungeon that he uses. If he has to roll a dungeon, he always pulls out this map, and you can of course put different things in it. So I started with this as sort of figuring out what my layout constraints should be, how big I wanted them to be in Mythruna. Should halls be 2 blocks wide or 3 blocks wide, that kind of thing. But then there's all kinds of stuff. I don't know if I still have. Yeah, so I had looked at all kinds of things. I kept this one up because I used this one as an example when I was originally working out sort of layout stuff. But yeah, the rolling the dice was one I had remembered from back in the day, and it was kind of neat to remember it. It brought back all kinds of memories. But yeah, just letting gravity and physics kind of determine your initial layout. So this is really interesting. The first random number we ask for is 0, and so we're only, for this particular seed, what seed are we using? Yeah, 42. So seed 42, we will generate these 11 rooms. If we change this to like 0, a different seed, we'll get a different initial random number, and so this will generate a lot of, or I think, 1, 2, 3, 4, 5, 6, 7, 8, 11 every time? No. That's suspicious. That's very suspicious. Do I? Yeah, seed 42. Yeah, I try to pick interesting ones that I'll remember. So that's interesting. that it, let's log numbers rooms. I think maybe I'm doing something else dumb. Because that's just two, numbers 11. Why is ran next int 10 always returning 0? So what if we pick seed 1? Maybe it just happens to be that 0 and 42 both start with 1. Oh yeah, this made a lot more rooms. Okay, so this made more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this made 16 random rooms. We probably ran out of space. Nope. We actually didn't generate 16 rooms. Alright. So it is working. It just happens to be that the two seeds I picked, the first random number we ask for is 0. And so we end up getting exactly 11 rooms. And we'll stay with that because that's what we were looking at. Okay, so we generate the feature rooms, and this is what I was talking about. You can imagine a grid here where each of these, you know, yeah, so I mean I can't draw a line here, but you can imagine there's grid lines here where it placed, you know, these to make sure that they were apart, and we left some empty. And so then the next phase is when we do the infill rooms. And so let's talk about how the infill rooms work, because we already talked about how those were positioned. So we create some infill rooms. So intersects test. So let me remember how this works. So you probably want to bound this grid by the outbounds of the rooms generated in the first pass, which I might have already done. Okay, intersect tests will check against neighbors, so we can tighten the grid for infill, i.e. no 1 unit buffer. Okay, so what is max infill size? Where do we get that value? Okay, so yeah, okay. So the rooms that are generated, yeah, we give odd results. So the feature rooms would be as little as 2, but as maximum of 8. And the minimum, the smaller rooms can be 2, you know, minimum of 2, maximum of 4. And so we build some, essentially we go through our grid, which is built in 2 by 2 cells, because a part of a room will never be smaller than 2 by 2. So we build that in. Anyway, we go through this grid, and then XG, what is X grid? Oh, I see. So we kept that grid, I believe, that I made in the first one. No, that's not it. What are we doing? X grid, min grid. X grid is the max infill size. Okay, so we're going bigger to smaller. Min grid is the min infill size. So so these are basically going through the sizes, XG, you know, the maximum size, every combination of, you know, 2 to 4, so, you know, 4 by 4, 3 by 4, 2 by 4, 3 by 4, 2 by 4, you know, so on. And then we calculate what, so a theoretical center would be for that, and then we see if that would intersect something already. We build a room that size and that position, and we see if that would, so we kind of like go through Yeah, so we pick one of those cells from here. No, we don't pick the cell. We go through. I see. So based on the size of the room, so in this map, our second pass comes through, and it's making, it checks each of these different grid sizes: 4x4, 4x4, 4x3, 4x2, and then it checks 3x4, 3x3, 3x2, and so on. And for each of these, it builds a grid on top of this to see. It goes through here and says, hey, can that room fit here? Oh, yeah, it can. And so then if it can fit there, we sort of randomly move it around in that space. And I thought that there was a thing that checked if you could even do it, like it rolls a dice. But either way, we'll see that it fills in. This is probably where the least understood. Oh yeah, here we go. So first we see, can a room go there, that particular location, and then we roll to see if it can, and we figure out what the chance that it should is, and then we see if the roll is less than the chance factor, and if that room can appear there, then we put a room there. And so we chance factor minus each chance delta. Yeah, and so each pass through, we like sort of reduce the chance factor, so that within a particular space we don't continually put lots of little rooms in there. And so what we end up with is, hold on. So the next pass we'll do this. What I should have done was, so let's take a screenshot of this, and then let's take it out again so you guys can see a little quicker than this one, and I'll show you what I'm talking about. Okay, so let's take a screenshot of that, and okay, so that's with just the feature rooms placed, those 11 initial rooms, and then we do infill. We added all of these because we found spots form or randomly decided rooms should go there. And so based on a starting frequency, we can decide how much infill and how little infill we want. So now that we have all the rooms, we need to connect them together. And there's a sort of algorithm for this as well, which is, again, from that random dice roll. If you find it, there's a couple different guys that talk about that. And I like this because it constructs the dungeon organically, and you also have kind of a, so let's get our rooms back. One of the reasons it takes so long to render is because of this giant field, and Blockhead was not meant to deal with that. So we've got all these, and what it does next is, so we connect all of the rooms to the other rooms. We don't really care. Yeah. We don't care whether they overlap or not. We do make sure that they don't. No, we just connect all of the rooms to every other room. Yeah, so a fully connected graph is what they call that, right? So this room would connect to every other room. This room would connect to every other room, and so on. So you're guaranteed full connectivity. And then, yeah. Then why do we have to then... Hold on a second. Oh, maybe we have two different graphs. See, you guys get to learn with me as I figure out what I did again. And we're not going to get as far as I wanted because we're just learning how this all works, but hopefully it's educational. I'm sure some of you got some interesting things out of that. So we check to see add all of the pending edges. An edge in graph terms is, that's another way of, so you have nodes or vertices, and then the edges are the things that connect them, also known as links. I pick kind of a hybrid of nodes and links because it's less confusing. Vertex is heavily overloaded. Edge is just so common in graphs, and even though you'd think it was used a lot in 3D graphics, it's not. And link is a word that is heavily overused in computer science, so, or computers in general. Okay, so we built, I see, okay. We built a graph that connected every room to every other room. And then we added all of those edges. No. What is current? The first room. Okay, so we added all of the edges of the first room, and the, yeah, whatever. We arbitrarily pick a first room, we add it. Clean the pending queue out up to the shortest unconnected edge. What is unconnected? Oh, so we created all these. It doesn't mean that we're going to make a tunnel between them. We connected all the rooms together. It doesn't mean we're going to make a tunnel between them. It just means that we've got a connection there, and we've got a graph that connects everybody together. Connected means we've actually put a tunnel there. So if we're pulling off, so how to describe this? So there's a priority queue, which is going to sort these edges by length, I believe. Get length compared to, yeah, so our length is compared to other ones. It tries to pick the shortest edges. Yeah, okay, I got it. So we build a queue from the current room, arbitrarily the first room. We're going to go through all the rooms. I think what we do is we pull all the edges for that particular room, sort it into length order. Graph, oh, so graph in this case, you understand what a graph is conceptually, then I will explain to you how I implemented it in Groovy, which is to use a multi-map. So a multi-map is like a hash map, except for you can have more than one value for each key. And so, so in here, if I put graph, put node 1, edge, graph, put node 2, edge, that same edge that connected those two, then I can look up the edges connected to either one, and an edge has a from and a to. Yeah, a room 1 and a room 2, so an edge connects two rooms. And so basically this graph is a multi-map where the keys are the rooms and the rayless values are the edges. And to save myself time, whenever I add an edge, I put it in both ways, so you can get to it in either direction, which means I need to dedupe it. But that means, yeah, so anyway, I hope that answered the question. So back down here, so we add, for the current room we're working on, we add all of the edges connecting to that room. So in this case, say this was room 0, it's connected to every other room, and we add all of those edges. We go through them in length order, so the shortest one first. If it's already connected, we skip it. If we've already visited either of the ends, so we already, say we already connected these two rooms in some other way, like earlier edges connected those, then we skip those two, so maybe this one and this one were connected, and anyway, so we skip those two, so we're only trying to find new edges. And so if this is the shortest, so basically we go through the pending list and we find the first shortest one that is still open to be connected. if that makes any sense. So we might have had, edges here. We tried this shortest one. If that's the one that was not already picked and was not redundant, then that's the shortest one we break. We're done. And then the shortest one we say, okay, we're going to connect it. We set it the type of tunnel it is, which is later on. I can use that for something else. If the shortest length is greater than the longest edge so far, we just keep track of what the longest edge is, just because I like to print statistics. Yeah, so just because we started on a particular room does not mean that it's part of the edge we picked. Have to check both ends. Right. So from the edge, now we have visited both ends. I just wonder if you guys are on like a 10-minute delay because I started the live stream so early. I hope that's not the case. So when if you guys make a chat down here, see how long it is before you see it pop up on your computer, and that'll tell you what the round trip is from when I will see it and from when I will respond to it. So we visited, we added the current. Oh, I see. Yeah. So as we traverse, if this was the room we picked and we had checked this was the shortest edge, obviously it is, and we decided to connect them, then this becomes our new current room, and we'll branch out from there. There's always a delay in chat. I'm just wondering if it's the short 30-second delay or the long, or if it got screwed up and made like a 10-minute delay because I started the live stream early before it was scheduled. And you guys are looking at a longer delay. I hope that's not the case. Anyway, so we started with this room, we decided this edge, and so now this becomes the current room, and we'll pick the next shortest edge and so on. And so we'll build sort of a graph of shortest edges, connected them, and there's some other stuff. Okay, 35. So thank you. And we keep track of how many long time we've done that. And so basically, as long as they're yeah. Oh, nice. Everybody's paying attention. Thanks, guys. And so, yeah. So as long as it's interesting that this kind of forces them all to be connected. At any rate, as long as we haven't visited every room, we will continue to find the shortest edge. Yeah, because the thing is, we added all the edges. We might not have gone through all the edges here. So when we started with this room, we added an edge to every other room, and then we decided, oh, this is the shortest one. I'm going to make a path here, blah, 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 blah. Oh, I shouldn't have clicked. We're going to make a path here. Now this is our current room, but we left all those other edges in because we started with the shortest one. So first, basically what we're doing is we're finding the shortest path through the dungeon. And then if anything is disconnected, we will go back and try another path until we have the whole thing fully connected, so that when you are done with this particular loop, what is this doing? So let's don't do this. And I'll label what it does when I'm done here. I think I get it. Oops, I missed one. Okay, so let's take a picture of this. We'll execute this again. We should get one more level deep. Oh no. Okay, what did I do wrong? No such property. Near pairs. Okay, so I didn't. Okay, keep plot the actual tunnels. The main tunnels we'll have to draw. Okay, so each of the edges. Okay, I think this is what I want, which is to show you the next step in the algorithm without messing up. Okay, so I took the near pairs thing out. We'll deal with what that does in a second. But so this should give us our first level of tunnels. This was just fully connecting the graph. Oh no. Why aren't you drawing the edges? Oh, I think I turned off. Ah, yes, right. I turned off drawing edges. Draw the connected edges. True. Okay. So this will draw the connections. Yeah. So this is the part that fully connected that graph, and I'll take a picture so we can move back and forth. So this is what we started with. You know, and then we found the shortest path through here that connects all of those rooms, and that's what this looks like. So these two guys connect. These two guys connect. Like, say we had started with here and we got all the way here and we connected everybody, and now we're at a dead end. So we picked the next shortest path that was, that's that one, and so we continue down here and we connect everybody down here, and up, we're down, so we pick the next shortest and so on. And eventually we've sort of done a kind of depth first traversal through the shortest edges to figure out a fully connected dungeon. Now this is fine for a maze, I guess, but it's not a very interesting dungeon. And so what there's the next pass then sort of randomly decides how we're going to, you know, connect some interconnections. And I'm trying to remember how this does that. So draw the connect. Yeah. Yes. Where's the one I commented out just now? Up here. So we'll put this back in. And so for every room, connect every adjacent room through real links. Okay, so we go through, we build a list of adjacent rooms. Okay, so for this room, so in graphs, there's a, so if we go back over here, you know, this is node A, this is node B, and maybe this is node C, right? And so if we're looking at node A, these are incident edges, and these are adjacent nodes, right? A connects to B, and A connects to C. And so what we're trying to do here is we're finding, because I don't have a real graph data structure in Groovy here, I made one. I can't easily get to the adjacent rooms, so I build a list here of the adjacent rooms for this particular room by going through every edge. If it's connected already, like because we connected it in this earlier stage, then I add it to the adjacent list so I know all the ways we're currently connected. And then so then I build this near pairs. If I don't remember, I'm not sure what I'm doing with this yet, but bear with me for a second. Whereas I go through sort of the n by n rooms in the adjacent set, and you know, there's even the redundant one because we've. Oh, I see. Yeah. Okay. So this is taking. So say we started with this room here. This was an adjacent room, this was an adjacent room, this was an adjacent room. So we end up with 3 rooms, and we connect all those together as if they're near. So they're in these near pairs. This one and this one, this one and this one, this one and this one. They end up in those near pairs. And then am I removing edges? No. So then all the edges that were left in the pending set, the things, so we had all the edges that all are connected to the rooms before, and you know, some of them we didn't connect. You know, these two have an edge, but we didn't connect them by a tunnel. You know, these two have an edge that we didn't connect them by a tunnel. These two have an edge that we didn't connect by a tunnel. So we go through all of those that we left behind, and or we make a new one, right? Any of the edges that are not connected, we any of the edges that are not connected, we add them to the pending list so that it's still shortest edge first. All the things that are anyway. So we grab the first one off of there. If its length is greater than the longest edge, so we want to find, when we built these edges, there was a longest edge, so maybe this one was the longest one. We want to make sure that any new tunnels we create are actually greater than that. Right, so, or no longer than that? That doesn't make any sense. No, maybe I guess it does. If the edge is greater than the longest edge, we skip it. Otherwise, we decide randomly. We roll 8, so big 50 chance that we decide to connect this edge, and we gave it a different type, so we know it's a different type. And so this, if we set this to true, and so then we'll see the next level where it decided to randomly fill in, these kind of edges. And let's run it again. Takes it a second because okay, so it connected some more. I'll make that a little clearer. So we were here, right? And then we connected some additional edges. Right? It made it more dungeon-like. And we still have like these isolated rooms off in the corners and stuff. Right? So we're good there. And so that's where we ended up. And we're almost done with the algorithm, and then I'll show you what it looks like to run around inside of it. So here's where we plot the actual tunnels, because so far in the algorithm we've just connected the rooms. Like we know this room is connected to this room, but now we need to decide the best way to make a tunnel between them. Should we have made a tunnel like this, or should we have made a tunnel like this? Which one's the shortest? And so that's a little complicated. I won't go too far into that. We'll just kind of breeze over it. And so we end up with what we showed up here. I think I ended up putting everything back, correct? Yeah, because those are debug stuff. Now that I put this here, randomly connect. What did I do with this near pairs thing? Yeah, I don't seem to have done anything with near pairs. What were we doing with this? Oh, I keep track of that for picking the right sides, because like this room and this room connect, but I know that anyway, there's a reason that I used it to decide which direction to make the tunnels, and I used those near pairs for that. So I think I fully randomly connect additional close rooms, 50 chance. Okay. And so once we've got a layout like this, I have this other dungeon generator which takes this and turns this into rooms and tunnels. So if we execute the script, and then I'm going to have to remember that here is where we want to drill into. Let's see, execute script. And it's working. Yeah. Okay, so we want to open up a tunnel right there. It's taking its time. Okay, so now I can go. Problem is when we're building such a huge area. And what I want to do, and the other pain here is that I can't easily place lighting because I can't edit and walk at the same time. It's not the greatest thing for, let's use fire. Let's see, a flame large, that's a good one. So if we place a fire thing in here, Oh, it's going to be super slow too because we're such a large map. So I'll just kind of give you a brief preview. So, because every time we place a fire, it's going to take it several seconds to render. But anyway, it generated a dungeon. It took those rooms that had a height, and gave them, height. We've got tunnels, and I think that at some point it puts no, maybe that was something else. It knows where doorways are and can place doors. But essentially we're running around a dungeon here, and I kind of wanted to get into different styles and stuff, but you can see it's kind of cool. Yeah. So, oh wow, it's a big room. Let's place some more flames. So I wish I'd had time. We're already 10 minutes over, because the first step I was going to do was have it automatically add lights. And you know what? Maybe we can really quickly. Okay, so we'll come back up here, and we'll go back to this other script. I can actually do this real quick. Let's grab. We can put a flame in the middle of every room. That shouldn't be too hard. So do I have flame already? No, I do not. So let's make a flame. Making proper lights that cling to the walls, that's a little bit more difficult. I think this is it. It will complain quickly if not. And so then here we can also... Oh, not there. Oh, we're filling in. That's what we're doing here. Oh no, we're going through. Okay, got it. I got it. Okay, so we want to set cell room loc x times 2 plus xs divided by 2. What is this x plus x min stuff though? Okay, let me decipher what this is doing real quick. Bear with me for a second. So we're getting the we're getting the size of the room. We are getting the minimum location. I see. And so x min would actually be what we want, plus half the size. And to be on the floor, I think we have to go 1, and then z min plus zs divided by 2, comma, flame. I think that will put a fire in every room. Oh, okay. No such property flame. Oh. Yeah, we've got to is it global types? Global types. Flame. Okay. 1 second. We'll have flames. Hold on. Bear with me. Just gotta get past these debug stuff. Set cell is applicable for. You son of a. So it's turning that into a big decimal. I really hate that Groovy does this sometimes. So then we have to come in here and cast the int. I didn't want them to be... There's probably a different division operator that maybe is... Okay, so cool. We should have... We should have flames in the sensors of the rooms now. Interestingly, I don't remember exactly how the translation goes. Let's see if it works. Okay, so this time we'll remember here. And we'll execute this guy. Hopefully it keeps my flames. Uh-oh. Okay, there we go. Alright, let's see if it put flames in there. We can run around a little bit better. Of course, this is not designed for this, but... Alright, here we go. Did it make flames? It did not. Alright, there's something else going on here. So the... I'm running around inside the walls. So why didn't it make... There's something in the translation because it moves the floor. Alright, one more try. Because I know I was doing this manually before. So I believe... if I set them in the corners of the... I'm not even sure if we're in the right place here, really. But if I take this... if I take this... Oh, I know what it was. We are putting those flames in the wrong place. Because I wasn't putting the map offset in. I bet they were up here. Yep, look, we can see all the flames over here. That's what it was. Okay, so let's try. Oh, and that should have been Z-min anyway, so that's the other thing that was wrong. So we found another bug by accident. Okay, so let's generate this again. Bear with me, guys. 1 second. I still show that I have 7 viewers. This must be an interesting topic. I should definitely pick some better topics coming up, like this. Okay, so we've got flames. I can see them. Let's see if this one destroys them or pays attention to them. Because it does some weird conversion to get... Okay, so I should be able to... Okay, somewhere. Come on, make a hole. Okay, oh yeah, that's right. For lower roofed rooms, I have to make 2 holes. I have to make 2 blocks. Okay. So let's jump into there. We should have lights this time. I hope. Oh, I can already see them through the roof. Yeah, because we had some sorting issues. Okay, so we've got... Oh no, I did not just do that. If you accidentally hit the space bar and move the cursor, it sends you back up into the sky where the regular orbit camera is. Anyway, we've definitely got flames, so let's go run around the room, and I will not hit the space bar again. I've moved my thumb off the space bar. Okay, so... Yeah, so put them in the air instead of... But that's okay, we can see... We can run around here and look at our cool, dark and spooky dungeon. Used to be I would print out the map or take a screenshot of the map. Oh yeah, check it out. I mean, can you imagine walking around here and come around the corner to an army of skeletons or something? Like swords and at the ready. But while I'm talking about this, so I wonder if that was a dead end. So because the dungeon was built like a human builds it, it understands the structure of the dungeon. It understands what rooms are near each other, what major rooms were connected together, and so on. And then it can use that to create different themes. So if you had one large room that was maybe a different kind of block style that can fade into the other tunnels nearby, and it knows this. So let's see how far we can back up. Okay, so that's just a corner. So anyway, so it knows things, and I can obviously expand it a lot. This was just a very basic idea. And it already makes some cool dungeons. Like you can run around here and really get lost. I have no idea where we started. Somewhere around here. Somewhere is, you know, that room with it's got the skylight. And I don't know where it is. It doesn't matter. So anyway, I think that's where I'm going to end it tonight. I wanted to kind of get it embedded into the terrain, but it took me 20 minutes to just move it on the map. So I will continue working on rivers, and maybe I'll leave this where it is so we can continue next week and embed it into the terrain and stuff, and then I can work on having tunnels that go not just side to side, but up and down as well, so we can have maybe some steps to connect the rooms. So yeah, if I hit space, then I should be able to move around and still control the... So anyway, I'm going to... where's my OBS window? Well, thank the patrons one more time. Thanks, guys. Thanks for all 7 or 8 of you who joined the live stream. That means a lot to me, having guys on who are responding to my stuff and listening. It really means the world that everyone is interested. And so, you know, thanks. If there's anybody else who you think would be interested in this kind of generation, because that's what we'll be dealing with for a while now, is different world generation. Next time we'll continue with these dungeons, I think, do some theming and some up and down stuff and embedded in terrain. I think we should probably be able to get all that done next Friday. And then maybe from there we'll do caves or something else. Caves are completely different than this. Anyway, thanks so much for joining, and I will catch you next time.